we are on board. You can start now.
Good afternoon. On behalf of Parul University, I, Professor Kinjal Shah from Electrical Engineering Department, welcome our today's expert, Mr. Nipun Chadalia. He is working as an electrical design engineer in GEA Vadodara. Now I invite Mr. Nipun Chadalia to share his valuable knowledge with us. Sir, you can start.
Thank you, ma'am, for the introduction, and thanks everyone for the joining here. Without any, further explanation about myself, we'll start with the topics. I'll be, sharing my knowledge on electrical control panel designing, which we know the process that we follow in the industries nowadays. So first of all, what is electrical control panel? Control panel is something which controls. Okay, that is a basic definition. And electrical control panel is something like a combination of electrical devices that uses electrical power to control various mechanical function of industrial equipment or any special machines. Like if there is a circuit breaker that will be controlling the light or fan, so that is a control device. If there is any controller which is controlling motor speed or something, that is control device. So the combination of all that components will be called as electrical control panel. Moving on to the next slide. See, this is the basic process of design and control panel, designing control panel followed by industry nowadays. So it's not something like that. I need an electrical panel. I will straightly ask the manufacturer, okay, I need this, and you give me panel. It's not like that. First, we receive input from the customer, the end user, that will be anyone, that can be anyone. After the inputs, and in all this section will go one by one in details. After the inputs, there will be initial sketch, that is single line diagram. So we create for single line diagram from the inputs that we have received from the customer. In single line diagram can be your manual made, or it can be done by the software. And then after the initial sketch, there will be a component selection. What kind of components you will require in the control panel to perform your desired task. After the component selection, there will be a complete design in the software. So now that you have finalized components and you have a basic sketch ready, you have inputs from the customers. Okay, the customer needs this much of controlling and everything. Now we move to the complete design in software. Complete in software, there will be a complete design like schematic, multi-line drawings, and everything, bill of material, and then there will be a cable reports and terminal reports and everything that will be done by the software itself. After the complete design, we'll move to the next, that is purchasing the materials. Now that you have finalized drawings and selection of components has been done, you will purchase the materials. Then after the purchasing materials, the panel build phase will be started. The panel build phase, it will be in-house. Workers and wiremen will build the panel according to the design that is built on the software. And then there is FAT. FAT, it means factory acceptance test. After this building of the panel, we will test in the in-house with approximate zero load. It can say with no load. So the panel will be tested in-house, and then if there are any changes required, it will be done in-house only before delivery or installation on the site. So after these changes, the panel will be delivered, or panel will be delivered to the customer or end user. on site, that will be on site. And then there is SAT. SAT means site acceptance test. So it's the same way, it will be done with the same way as FAT, but here in case of SAT, we will run the control panel with the actual load. What are the motors we have, what are other loads we have, light or anything. We will run the control panel with the actual load, so that we can commission the process and rectify the changes if any change is required. And then final changes on site after the SAT, if you require any changes on the control panel. Let's say if one motor is draining more current, and you will need the overload relay will be much higher rating, then you'll have to change it. So that is final changes on site, and then the panel will be ready to perform. So that is how the flow works in industries. Am I audible, right?
Yes, sir.
Okay, thanks. So now we'll go points by points in details. Input from customer and end users. So what kind of inputs we can receive from customer or end users? Type of application. What kind of application he or she may have? Like if it's a special purpose machine, or some bigger plants they have, like liquid plants or powder handling plants. So that are the type of application. And then basic process flow. If there is process field process line, field process line is then customer will give the process flow, like, okay, first I need this process, and then after this completion of process I will need that process. And that is something like interlocking of the process in, and how the process of the manufacturer works. Like if any manufacturing plant is there, then you will have a raw material first, and then something cooling or heating, whatever it is there, and then after that some other process has. So that is basic process flow that will be required from the customer. And then there is special wishes. If any customer wishes, I need this kind of plant or something, like if they wishes to have some particular switch gear manufacturer, like we have a various manufacturer of switch gear, like L&T is there, Schneider is there, Siemens is there. If any customer requires have a special wishes that I only want L&T or Schneider switch gear, then there are special wishes. So these are the inputs from the customers, the basic inputs that will require to move on further process. Now the initial sketch that will be a single line diagram of the plant or the control panel, whatever it is. So single line diagram will consist basic components. That will be your main main incomer will be there, and then all the points will be shown as only single line. There will be no other, like if we have three-phase supply, then the three-phase will not be like shown with three lines. It will be only a single line. So that is the single line diagram. And the single line diagram will also consist of all the loads that we are going to control. And then we move to the component selection. After the single line diagram or initial sketch, we will move to the component selection. The component selection is a very important topic here for the control panel design. In the component selection, there are various components. Like for the electrical control panel, there is an enclosure, that is cabinet that we call. So we will move one by one for the components. For the enclosure, there are various type of enclosure, and basically these are the points that we keep in mind while selecting the proper enclosure. Like in terms of material, there are sheet steel material, stainless steel or fiber. Basic enclosures are there, and then there is a required protection. So these are the two basic points that we keep in mind while designing the enclosure. For the required protection, there is IP ratings, there is NEMA ratings, there is EX rated. We will see this in next slides. So these are the two main points that we consider while designing enclosure or selecting the proper enclosure, the cabinet that we require for the pen. The IP ratings. IP ratings is an international standard, IEC 60529, used to rate the degree of protection, or you can say ceiling effectiveness. Like, so this is the basic chart here. IP6 IP, and there is 2 digits. The first digit is for the solid protection from the solid materials, and the second digit is for the protection against the water. So like if I have IP65 rating of the enclosure, then I will have for the 6 here, you can say there is a dust tight, so no dust will be enter in the enclosure panel, or no ingress of dust 2 to 8 hours. Like if my panel is in a mining area or something like that, there will be continuously dust. So up to 2 to 8 hours, no single particle of the dust cannot be entered into the panel. Same way for the water, there are various criteria for the waters. So let's say if we have 65, then the water jet, like there are various kind of scenario where water can be affecting the control panel. So if we have selected IP65, then the 5 is for the protected against jet of water, limited ingress pattern. It means if you have in a jet throwing to the control panel, that will be protected if we have 65 IP65 rating. So most common IP ratings that are used in industries are IP55, IP56, and IP65. And there is IP68 also. So IP68 will be the highest of the ratings. NEMA ratings, we in India, we generally don't use NEMA ratings. They are basically North American standards. So, and NEMA ratings does not only consist this dirt and water. They also consist this oil and coolant, corrosive, or submersion, and other parts. So there are this much of following environment conditions that can be protected in NEMA ratings. In NEMA, we in general there is 4 and 4x rated panels available. That also depends on the application or the environment of the plant or the outer atmosphere of the enclosure that enclosure will be placed. EX rated panels. EX, you might have seen this symbol of EX in some of the instruments or in panels. The EX rated panels, it means it is protected against hazardous area. Like in some delicate area, there might be a chance of having fire or due to the spark in the panel. So in such cases, you will need EX rated panels. So EX rated panel will be safe, will be a kind of safe panel which will prevent the spark to interact with outer atmosphere, so that you can prevent the injury to the people's working around, and also the equipments that are operating outside the panel. So that is 3 main points that we consider while choosing the protection of the enclosure. And there is type of control panels. After the enclosure, what kind of control panels you will be needed for the application? So basically there are 2 types of control panels: manual controlling and automatic controlling. In manual controlling, there is a PCC, MCC. PCC, it means power control centers, basically distribute the powers to the sub panels or other feeders. And then there is MCC, it means motor control center, which is basically controlling the motors. And then for the automatic, this PCC and MCC can be automatic by means of controlling somehow. If you have a PLC is programmable logic control that we all know. So the PLC control panel will be like controller to the system, like it will control the power control center and also the motor control centers. So basically we in terms of controlling, we have two types of control panels: manual controlling and automatic controlling. We will see each panel in detail. Power control center, a PCC panel also operate like electrical power distribution panel, is a module in an energy supply system that divides an electrical power, that the power that is coming from the grid or substation, that will be divided into subsidiary circuit. Like if we have any big commercial building and there is one power coming from the grid or generator, whatever we have, that power will be divided into sub panels. Like if we have four floor of commercial building, then we will have four sub panels, like floor wise. So that power supply for that sub panels will be given from this PCC. So that the PCC will be only one for the building. So that is only one control center for the power. And power control center will basically have only circuit breakers and some protection device and bus bars only. So the input power which is coming from the grid or substation will be divided into the sub panels likewise, with protection. The primary goal of the panel is not only to properly distribute incoming power, but also to protect the subsidiary circuit from overload and short circuits. So which is basically covered from here. You see this, you see this, this is the air circuit breaker. So it will have protection facility, either it is overload or short circuit protection, and the main power is coming to the circuit breaker, and then it will be distributed to the sub panels. Like this below feeders will be going to the sub panels. That is the basic principle and operation of the PCC control center. Now in PCC we have like circuit breakers. So how you select circuit breakers? So these are the points that we keep in mind for the circuit breaker selection. What is the task of the branch circuit of feeder? Like if we have just shown here the PCC, like if we have application of like commercial building, then the task of the branch circuit will be like controlling the lights or fan or AC, air conditioner, or whatever we have. That will be a task of a branch circuit or feeder, which rated current settings range. So here we will calculate the total amount of load we have. Like if we have commercial building, then we'll have to calculate the total load. What are the instruments are there? Like if you have AC, fan or motors, everything will be calculated likewise. And then after the total current, the rating of the circuit breaker will be decided. Then there is a breaking and making capacity. That is something like if we have short circuit scenario or something like that, then there is this breaking and making capacity. That is also a kind of rating of the circuit breaker. That is also an important factor. And then any special requirements here for the circuit breaker, if we have any auxiliary contacts, like if I need any signals when the circuit breaker is tripped, then that there are special requirements. Which type of coordination? There is one this coordination factor which will be needed to calculate for the circuit breaker. There are basically two types of coordination: one coordination type 1 and coordination type 2, which basically covers the safety of the instrument and the safety of the operators. Like in the coordination type 1, you will have a protection of the circuit breakers, but not the operators. So that is something like harmful. But the type 1 coordination circuit breakers will be much cheaper than the type 2 coordination. Type 2 coordination, that consists safety of the operators as well, the circuit breakers also. So type 2 is not much widely used, but because of the high prices. So that is the coordination of the circuit breaker. What is the mode of mounting? And now in this case, we have like two modes, like circuit breakers can be mounted horizontally in the panel or vertically in the panel. So that also, affect the selection of circuit breakers. The cross section of the connecting wire. So what will be the cable that is outgoing from the circuit breakers? So that will also be taken care while selection of the circuit breakers. So depends on these parameters, we will select the appropriate circuit breakers. Now, selection of bus bars. The bus bars are basically current carrying devices, which is basically used while we have, a higher level of current, like 1000 amperes or 2000 amperes. It can be used it can be also used to 200 to 250 or whatever the small amount current. But in general case, we use bus bars while there is, higher current. So for the bus bar selection, we have this formula: bus bar current carrying capacity, that will be ampacity factor into bus bar width into bus bar thickness. So if I have to select any bus bar for a particular application, then I will use this formula to calculate the current capacity of the bus bar. Like ampacity factor will be different for the different materials. There is a copper bus bar, there is aluminum bus bar, there is galvanized iron bus bar, and there is silver bus bar. In industry, generally copper and aluminums are being used, and in majority of cases it will be aluminum. So for the copper, it will be 1.2. So if I have to calculate the copper carrying current carrying capacity of the copper, I will put 1.2 here, and then let's say if I have a 30/12, then it will say the current carrying capacity. So likewise, I'll decide the current selection of the bus bar. The length of the bus bar is not much necessary in this case. You will only have to take care of the bus bar width and bus bar thickness here. Length can be negligible in terms of current carrying capacity. So after this PCC, we have MCC, motor control center. Motor control centers, MCC panels that are used to control. The definition itself says that they are used to control motors. They control the motors and actualize the performance of an performance of it. So MCC basically consists of motor starter, because we have only motor to controls from the MCC. So it will basically consist of this motor starter, and that we are aware of this motor starter, and that is DOL, direct online starter, star delta starter, and soft starters we have, and then variable frequency drives. So selection of motor starters, that will also be depend on the application, what kind of application you have. If you have, let's say you have one motor and you need only on off control, so that is one application. In other application, if you need like motor is having variable speed, like in some time I have to decrease the speed, sometime I have to increase the speed, that is kind of application we'll need to take care while selecting the motor starters. And also the size, what kilowatt motor we have for the starter. So based on that, the motor selection starter selection will be done. And type of protection, like if you need overload protection or something like that, then that is type of protection. So these are 3 points, basic 3 points that will be taken care while selecting the appropriate motor starter. So we have already seen this type of motor starter. We have basically 4 type of starters. Direct online starters, that will be a basic like supplies coming from MCB, and then it will be going to the contactor, and then contactor will supply to the motor. If you need overload relay, if you need overload protection, you will need to insert the overload relay in between the contactor and motor. So that is basic circuit of the direct online starter and DOL starter, which will not control the speed of motor. And then we have star delta starter. Star delta starter is basically direct online starter, but for the higher rated of motor. When you need, when you need to control for the higher motor, you'll need to, control the limiting current, starting current. When the higher rated motor gets started, it will drain more current. So in that case, direct online starter will not be in much used. So in that case, star delta starter will be used. Soft starter. Soft starter is something like a dual starter, but in case of much higher rated, like when you can't use star delta starter itself has a limitation up to some amperes. So after that, you will need to use soft starter. And soft starter and variable frequency drive. Variable frequency drive, that is widely used nowadays. Variable frequency drive, that is used to control speed of motor as well as many other protection. The difference between soft starter and variable frequency drive is soft starter cannot control the speed of motor, but variable frequency drive, it controls the speed as well. So these are the basic motor starters, and then we have programmable logic control panels, PLCs. PLC panel are small panels with modular components designed to automate customized control processes. Likewise, like I said, if any customer requires an automatic process, that will be the PLC will be needed for the project. So that is PLC control panel, and often they are used to control like motors, pumps, lights, fans, circuit breakers, and other machinery. So all that equipments you can control via the PLC. So here you can see this picture is a PLC control panel, which basically consists of the PLC rack and the supplies and some terminals. And they will not have any more motor starters or main circuit breakers for the feeders, everything, but it will have only input output cards. So here the panel usually consists of controller and IO cards. Two types of PLC panels are there: local PLC panel and remote PLC panel. In case of bigger area where you have a bigger plant, you cannot run the wires from the only single panel to the every instruments. You will need remote IO panels, which will be located near to the instrument, and then from that remote IO panel, the communication will be done via Ethernet or Profinet. There are network connections will be there between the PLC, two PLCs, or if we have a input output card, that will be controlled by PLCs. So that is PLC control panels. And then selection of PLC controllers. For the PLC controllers, we'll need to select the PLC that is controller that is controlling everything. These are the points that we take care while selecting the PLC controller. First is application. Application will be everywhere. What kind of application you have? Like I said, if it's a plant or special purpose machine, whatever, that is application. What input output capacity is required? If it's a bigger plant or if it's a smaller machine, the number of input outputs will be varied. So that also is a important factor for the selection of PLCs. What type of input outputs are required? That depends on the instruments that are in the plants or machines. Like if you have only digital signals coming or going to the PLC, then you will need only digital input outputs card. But if you have analog instruments also, like if you have a level sensor or temperature sensors, then it will require analog inputs or outputs, flow meters, that are the analog instruments. So that depends on the type of instruments you have, and then what size of memory is required. Memory, it means when you program this controller, how many lines of program you have, that depends on the size of the memory. If you have a bigger program, then you will need a more memory in the controller. So that is also important factor. What speed is required of the CPU? Speed, how many frequency of this controller. If you have any special purpose machine which is which requires very detailed attention, but in the speed, then you will need a higher speed of controller. In general cases, you can use the normal PLCs. And electrical requirements, what kind of power required is there, like we have AC power requirements or DC power requirements, so that is also important factor. Then communication requirements, whether you are going to communicate to the other panels, or if it's a single panel, then there is no communication required. And in terms of communication, there are various types of communication. Like I said, there is Profinet, Ethernet communication. So the type of communication will be also taken care while selecting the controller. Then there is software, which basically depends on the manufacturer nowadays. When you select an PLC, you can only use the software that is from the same manufacturer. You cannot like if you have Siemens PLC, you cannot program your controller in Schneider software or Rockwell software. You only have to use the Siemens software. So that is a software requirement. And operator interface, whether HMI, human machine interface, is required, or SCADA, that is operator interface, whether you want to give access to the operator. So that is operator interface. And physical environments also. So what kind of physical environments is there where my PLC controller will be placed? So these are the points that will be taken care while selection of PLC controllers. Now we have complete schematic diagram in software. The next point after these component selection, we'll move to the next point, that is complete schematic in software. So there are various software for the electrical designing that is being used nowadays. That is ePlan on AutoCAD and E3SEE. So ePlan and AutoCAD are most widely used nowadays. You see here the pic, that is ePlan software, that is snip of ePlan software, where you can design everything. Like if you have a PNID, that is process and instrumentation diagram, you can also design the process and instrumentation diagram. Then if you have a pneumatic panel, like if you have a tube and valves that are going and coming back, you can also design that. And the general electrical feeders like motor and drives and everything, then you can also have ability to check on the real, like something like 3D view. You can also place the equipments that are being used in the panel, and you can realize the space will be required, how much space will be required, and how much instruments, cable sizing, duct sizing, that will be done by the software. So that there are software, these are software basically. What are the outputs you will be getting from the software? So these are the outputs that you can get from the software. Once you design, you can have your complete schematic drawing, that is basically consisting of all the feeders that you have, like motors or any instrument sensors, flow meters or everything that is field instruments and motors and everything that will be in the schematic drawing. Then there is general arrangement of the panel, like how many components are there in the panel and the general arrangement, what component will be at which place in the panel, that is general arrangement. So that is that you can also design in the software. That then bill of material, the software can automatically, once your design is finished, you can also export the bill of material. Likewise, how many instruments are there and what kind of prices they have, and then total bill of material you can extract from the software. Then there is cable diagram. You can export the cable diagrams that will basically show you which cable is connecting from which instruments to which instruments, or every connection that is going outside the panel or inside the panels, that will be in cable diagram. So you can just check the cable diagram and see, okay, this instruments is connecting to this instrument or this field instrument, everything. Then there is terminal diagram. The cables that are going outside the control panels will be connected to terminals. So you can generate the terminal diagrams in the software. So you will have ability to check whether my cable is connected to this terminal or this terminal. So that is a terminal diagram. And then there is network architecture. In case of we have like 2-3 controllers or many field RIO panels, then you will need controlling of the each panel by means of only single controller. So that is falls in the control architecture. So you will be able to export this control architecture. On the control architecture, you can check, okay, my this much of panels will be controlled by this controller, and rest of the panel will be controlled by this controller. So that is basic architecture of the network. And then there is PLC IO list. PLC IO list will basically consist of the details that are connected to the PLC inputs or outputs. Like if any push button is connected to any digital inputs, so that PLC IO list will tell you that, okay, this number of input of the PLC will be connected to the push button. Or if any analog instrument is connected, like if we have any pressure transmitter connected to the analog input, that PLC IO list, you can check whether this instrument is connected to which number of PLC point. So that is PLC IO list. So these are the automatic generated reports that you can get from the software. The schematic drawings that you can design via manual, or there are some software which supply the automatic processing, that you can create one macro, standard macro, and based on that macro you can generate your drawings automatically. You just have to fill up some data, like if you have any motor feeder, then you will have to only fill the data of motor size and cable size and everything, and then the software itself will generate the automatic drawings. Now we have cable selection here. So cable selection are basically an important factor that the cable selection will be done by this much of points. We have cable installation, that is area of installation of the cable, whether my cable is going outside the panel or whether it's inside the panel, or whether it's in a hazardous area where fire or anything is there, delicate area. So that installation or area installation will be also an important factor for the cable selection. Then there is voltage, how much voltage will be supplied via cable, that is also an important. And then temperature, so what kind of atmospheric temperature you have, because we have seen in studies that temperature is a big factor affecting the current and voltage in the cable, because it affects the resistance of the cable, and then it will affect your current carrying capacity of the cable. So that is temperature is there, and then current capacity, what how much current I'll be needed to carry through the cable. So that will be a current capacity, and then area of application. Like it's similar like this cable installation. Area of application will be like what kind of area you have if you have pharma sector, if you have liquid and powder or anything like that, that will be your area of application. This is the standard chart we have. You can always get online. So it says the current carrying capacity here, and you have two measuring units for the cable size. We have AWG, that is American wire gauge, and we have mm². We use in India we use mm² as a standard unit for this cable size. So you can see here, if you have a like if you required a 5 ampere current carrying capacity, and then you can go for the 1.5 mm² cable up to 1 meter. If you have a 2 meter, then also 1.5 will be. So likewise, the length will be also and affecting this current carrying capacity. And these are the standard wire sizes available nowadays in the market: 0.75, 1, 1.5, 2.5. So these are the standard cable sizes that is available in the market. So that was for the cable selection. Then once you select cable, for the wiring purpose, you will need cable ferruling. Cable ferruling are nothing, just the numbers or names of the cable that will be put it over the cable to rectify or to differentiate the cables from each other. Like if you don't have ferrule, you cannot just simply check the cable and say, okay, this is going to this instrument. You will need to give a name. So that is cable ferruling. So cable ferruling will be kind of a PVC material tubes that will be covered on the both end of the cables. In the cable ferruling, there are 2-3 types of ferrules we use in the industries. That is general ferrules, and then number ferrules and cross ferrule. General ferrule, it means if you can see this picture here, they are general ferrules. Like if you have a 220-volt wire, you just simply give a name to 220-volt wire. If you have a 24-volt wire, you just give a name. So that is general ferruling. And then you have number ferruling. You in the design, you define some numbers to the cable. Like if you can see here in the next picture, there are numbers given. And then you have cross ferruling. So cross ferruling will be much easier for the installation purpose, because that consists of the source and target data. Like if you can see here, this MCB FM62 will be having this ferrule. So that ferrule will also consist the data of this MCB. You can see here FM621. So 1 and 2, that is how it is shown here. And then after the slash, you can say is DBU, that is the target. So you can just put any check any wire ferrules, and you can say, okay, this cable is connected through this MCB to any other field instrument or whatever. So that is cross ferruling. And cross ferrulings are mostly used nowadays because it's easy for the installation purpose, and in the time of maintenance, you can just check on the wire ferrule and connect the wires accordingly. In case of this numbering ferrule, you will need to check the electrical drawings, what number is used for which instrument or which feeder. That is a bit difficult. But in case of cross ferruling, there's no need to check on the drawings. You just need to check on the ferrule and the component name that is given to the every component. You can just check this ferrule and connect the wires accordingly. Now we have cable tray size calculation. Cable tray size calculation, we have general formula, that is total number of cable into area of cable. So if you have 10 cables of 10 mm square, then that will be 10 into 10, 100 plus we put some spare over here, so that, in case of future requirements, you can, always have some space. So that is the basic formula we follow for the cable tray calculations. There are various kind of cable trays in the panel. These are the general type of cable ducts used in the these days. Now we have terminals here. So we have various type of terminals here. Terminals, there are power terminals, which is basically used for power wiring. We have earth terminals, which are basically used for the earthing purpose. You can connect the earth wire to the earth terminals, and then there are single tier terminals, which is basically a normal terminal, and the multi-tier, which means we have a multi-level of connection. Like in the single terminal, you can put more than 2 wires, 3 wires, 4 wires, whatever the level you have. So that is single wire, single tier and multi-tier terminal. Then you have fuse terminal. In some cases, in some application, you will need, protection. So that fuse terminal will be having a fuse inside the terminal. So you can always, select the appropriate fuse size, and in case of short circuit or anything, the terminals will be get blown, and the instruments or the PLC connections will be in safe side in case of fuse terminal. But if you have a normal terminal, you cannot protect your PLC inputs or anything. So in general case of PLC, we use for the inputs, like if we have digital inputs or analog inputs, because for the inputs, power is coming out from the outside of the panel. But for the outputs, the fuse terminal does not require much. So for the digital inputs and for the analog inputs, we use fuse terminals. In between the instruments and the PLC connection points, we use fuse terminal. Then there is terminal blocks. Terminal blocks are nothing but just a bunch of blocks of terminals. You can, always, connect one single wire and then distribute that other ends of terminal throughout the panel. So you just don't need to connect every wire to the every terminal. You just, if you have a 24-volt distribution supply, like there are 10 instruments that will need 24-volt inside the panel, then you just, connect one 24-volt to this terminal block, and then you can get 10 outputs from this distributed blocks. So that is terminal blocks. This terminal block selection or any terminal selection will be based on the cable size and the type of potential. Like if you have a bigger cable that is connecting to the terminal, that it will require a bigger terminal, bigger size of terminal, and type of potential. If you have a 3-phase power coming to the terminal, then the terminal type will be different than the single phase terminals and 230-volt. So type of potential will be there. If you have a neutral, then the terminal for the neutral will be different. If you have earth terminal, then the earth terminal will be different. So likewise, the potential of the terminal will be also affecting the selection of the terminals. Now you have enclosure size calculations. Once you decide what components are there in the panel, you will need to calculate the size of the enclosure. The total size of the enclosure can be calculated by means of this formula, that is total area of the components which are being used inside the panels and some spare person. We always put some spare person. You can see here this rack is empty, this here is empty space. So in case of future, if I need to insert any device or anything, then I will be in safe side. So that is a spare percentage. We generally in industry we use 20 to 25% or 30% up to 30% spare. We put that spare space here, and then the total area of components. After that, you can have your enclosure size. What kind of enclosure size you will be required for the application. So you can decide the size via this formula also, and via the software. So you just need to put everything in the panel that is going to be in your panel, and then you can decide, okay, this much of space I'll be needed for the enclosure size. And then after that you can select this size of the enclosure. Now we have IEC. These are the standards. After the enclosure size, we follow some standards for these designing purpose. So there are two basic standards, IEC standards. One is IEC 60204, and there is another standard called 61439. So 60204 is basically consists the safety standard. So 60204, it will be for the machinery safety, like general requirements of the electrical equipment of machines. That is, and the scope of IEC 60204 will be given below given points. That applies to the use of electronic equipment and system for machines, and then starts at the point IEC 60204 will be considering, we can consider that standard from the start of the electrical connection point to the up to the machine level. So if you have any single connection, from that connection to the machine level, you can apply the 60204 because it's a safety standard, and that will be required for these control panel designing. And then it relates to the panel. So there is a range here, voltage range, on which this standard is applied. So you can apply this standard from voltage range 1000 to 1500, that is 1500,000. So you can 1k volt to 1.5k, you can have the standards. And then there is another standard, that is 61439. That is standard for low voltage switch gear and control gear assembly. Low voltage switch gear, that is basically everything we have seen so far in the component selection. Like if you have PLCs or any circuit breakers that is operating on the 230 or 400 volts, they are a low voltage switch gear. And the assembly, control gear assemblies. So when you assemble these components onto each other, like if you have a contactor and overload relay, you can assemble them together and then create an assembly. So that is control gear assembly. So all this is switch gear and control gear assembly will be having some defined rules, how you can assemble the control gears, and how you can define the size and everything, how you will be having some space between two controllers. So that are the some standard thumb rules which is defined in this standard 61439. So 61439 consists several parts. There is two parts here, 1 and 2, which is the part 1 applies to switch gear and the part 2 applies to the switch gear assemblies. So there are two standards in this 61439 itself. So that was the basic presentation of the control panel designing. I hope everyone likes it. So that was it from my side. You can take over if you want.
Thank you, sir. If you have any questions, you can ask. The session is open for question answer. Thank you, sir. On behalf of Parul University, I heartily thankful to Mr. Nikun Shadalia for sharing his valuable knowledge about control panel designing. I hope all the participants will be benefited with the knowledge shared by Nikun sir. Thank you so much, sir. So we will end our session here.
Thank you, ma'am. I hope everyone likes it.
Okay, thank you, sir.
Thank you.